Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Hi, this is Jeff Carpenter. This is another episode of the Distributed Data Show. I am here live in the studio with Mr. Patrick McFadden.
Hi there, Jeff. How are you?
And I am joined via the interwebs by Mr. David Gilardi.
Hello.
And as usual, we have Luke Tillman.
Hello, everyone.
And I am excited to share that today we have a complete set of evangelists. Yes, that's right. Joining us from Paris, France, or there or thereabouts, is Mr. DuyHai Doan, and we will be enjoying talking to him today. He is frequently all over the place in Europe, not just doing his evangelist thing, but supporting our sales engineering teams out there as well. So he gets a lot of customer interaction and has a lot of great things to share with us.
Yeah.
Hello, everyone.
Hey, DuyHai. We have questions today, lots of questions, and so this is the thing that I feel like you could bring a lot of really interesting stuff to this show because you've got great stories. You've been out there, you've seen some interesting things. I'm always riveted by some of the stories you run into. It's quite amazing. But so today we're going to ask some questions about that. And so first of all, what is going on in the field? I mean, you've got some interesting stories. Can you pick a couple for us?
Oh, sure. So recently I has been involved with an user, and I just realized that even seasoned Cassandra people still get confused about high availability. In their mind, the more nodes you have and the higher availability you get, which is completely wrong. So let's say you have a cluster of 100 nodes, right? And if you set your replication factor to 1, and if you lose one node, you will lose 1/100th of your data. And therefore, you are no longer strictly highly available. So indeed, the high availability is more dependent on the replication factor. The more replicas you have, and the higher the availability. You also need to take into account the consistency level to be used. For example, if your replication factor is 3, and you are using consistency level 1, you can afford to lose up to 2 nodes at the same time. And if you are using consistency level quorum, you can only lose 1 node because quorum requires you to have at least 3 replicas out of 2 replicas out of 3 to be online in order to be to execute the request, in fact. So to increase your failure tolerance, you can sometimes choose, I have seen very few people, in fact, they choose to have replication factor equal to 5. And in fact, in this case, with consistency level 1, they can lose up to 4 nodes by 5. So you can lose up to 4 nodes without compromising their availability. Or they can lose up to 2 nodes at the same time if they are using consistency level quorum. So, long story short, the replication factor is, in fact, the key to get high availability. Majority of Cassandra users, they will choose replication factor 3. In some rare case, when they need immediate consistency and the availability to lose 2 nodes at the same time, they will choose replication factor 5. But the price in terms of storage is quite expensive.
So wait a second, back up. You said replication factor of 5, which, I agree you almost never see in production. So what, explain to people listening, what is the rationale? Why would someone choose to use a replication factor of 5 and be able to tolerate 2 replicas going down like that?
So, excellent question. So, indeed, there is a real niche use case for this requirement. So, imagine that you are performing some rolling upgrade on your cluster. So, it's very classical scenario. So, it means that you have 1 node offline for a short period of time to put the new binaries and to restart the node, right? And if you are unlucky during this period of time and another node goes down, you will lose availability, right? So in some rare case, and if you are really a paranoid Cassandra ops, you may want to have replication factor 5 to shield yourself from this scenario. But really, to be honest, I find that it does not work to pay the cost for 2 extra copies just for this edge case.
Okay, all right. So fair enough. But I want to come back to the number of nodes, right? How does it impact Cassandra operations then if high availability doesn't depend on it?
So in fact, the number of machines in your cluster will determine how your workload will be distributed. The smallest Cassandra setup in production is usually 3 machines, right? And if you want immediate consistency using quorum, you should have replication factor 3. But then it means that each of your node will manage 100% of your data. And in fact, there is no real data distribution in this case. Now, let's say you have 4 nodes and you keep your replication factor to 3. Each node will manage now 3/4 of your data, which is slightly better, but not that great. And having 5 nodes means that each node will manage now 3/5 of your data, right? So as we can see, the more machines you have, and the better your workload will be spread out. And of course, we make the assumption that the token range are allocated evenly and there is no data skew, right?
So, all right, I want to get back to a point that you made, and I think this is really important for people who are at least not heavily experienced with using replication factor and what that really means. You say, if you want immediate consistent using quorum, you should use RF equal 3. Why RF 3?
Oh, thank you for asking this question. It will allow me to highlight some classical caveats that Cassandra beginners, they get caught with. So let's set aside replication factor 1 because it's nonsensical for production. Now, we have the choice between replication factor 2 and 3. When you are using quorum for immediate consistency, it means that you need a strict majority. So if you have 3 copies of your data, the strict majority is 2, right? But now if you have 2 copies, the strict majority of 2 is 2. So in this specific case, consistency quorum is equivalent to consistency level all, and it means that you give up on high availability if one node goes down. Interestingly enough, I have seen some experienced people, they did crazy things. So they use replication factor 2, of course. They are writing at consistency level 1 to have high availability. And they are also reading with consistency level 1. But you know that you can set, there is a parameter, you can set the read repair chance, which is a property of your table. And those people, they are setting read repair chance to a value very close to 1, so that it is pretty much equivalent to read your data at consistency level on. And if you lose one node during in production, the read repair will still succeed because it is not a hard requirement to have 2 copies of data. So it is a really exotic, I would say, exotic usage of Cassandra.
Okay, so would that be the same thing, or could you get the equivalent behavior if you used the consistency level all and then the downgrading consistency retry policy on the driver side?
Pretty much, in fact. But to finish, I would not recommend people using this trick because, you know, having replication factor 3 is much more safer. You do not need to twist your mind. And in fact, the difference between replication factor 2 and 3 is not that much expensive. You are just paying for 1 extra copy. That's not a big deal, really.
Yeah, and that's probably especially true when you have more than one data center. So you're already, duplicating your data. So more than one copy really isn't that big of a deal, right?
Yeah, and talking about multi-data center, again, Cassandra beginners, they get always surprised during my presentation when I told them that 100% of their data is replicated in each data center. Indeed, even if they belong to the same cluster, each data center has its own replication factor, and it makes things a little bit more complicated to reason with consistency level. So suppose you have two data centers, right? DC1 and DC2. In DC1, you set replication factor to 5, and in DC2, you set replication factor to 3, so 5 here and 3 here. Now, on the cluster level, you have 5 plus 3 equals to 8 copies of your data in total, cluster-wide. A request which is using consistency level quorum, now we can put a strict majority of the total number of copies. So it means that quorum requires 5 copies out of 8. And if your client is connecting to data center 1, which has 5 copies, it is likely that all the 5 copies in this DC will reply back faster than the other copies in DC2. But if your client is connecting to DC2, which has only 3 copies, you are pretty sure that every time you will require 2 extra copies from the other DC. And in this case, you have a huge impact on your latency. Another tricky consistency level is each quorum. So each quorum means that for each request, we require a strict majority of replica in each DC to reply, right? So with our example, in DC1, we have 5 copies of data. We require that 3 copies out of 5 should reply to your request. And in DC2, where we have 3 copies, we require that 2 of them are replying to your request. So when you are using each quorum, you will give up for sure on high availability whenever a whole data center goes down. But the advantage of this consistency level is that you are guaranteed to have your data consistent across data center. So this is the price to pay to have consistency across data center, guaranteed.
Okay, so what if I want strong consistency across my data centers, as well as being able to survive the failure of one of them?
This is a very interesting question. So I have been challenged recently with some user, and they want exactly this requirement. So let's start from the beginning. In order to have strong consistency across data center, we cannot use local 1 consistency level or local quorum, of course. So we move them out of the equation. If we use each quorum, as I said before, we lose high availability in case of one data center failure. So now, what do we have left? We have only quorum left as an alternative. And now the trick is how to choose the correct number of data centers and the correct replication factor in each of them to fulfill the requirement. So let's start. If we go for 2 data centers, for example, 3 copies in data center 1 and 3 copies in data center 2. So now we have in total 6 copies of data, and a global quorum on 6 require 4, right? Strict majority of 6 is 4. So it means that whenever one DC goes down, your quorum cannot be achieved, right? Because you will always have 1 copy of data missing. If we choose replication factor 5 for DC1 and replication factor 3 to for DC2, the quorum of 5 plus 3 equals 8 require 5 replicas. So if DC1 goes down, again, we are basically back to the previous situation. Now, if we have 3 data centers, it's become more interesting. 3 data centers, replication factor 2 in each of them. So 2 plus 2 plus 2 equals to 6. To have a global quorum out of 6 copies of data, you require 4 of them to be online. Whenever one DC goes down, you lose 2 copies, but you still have 4 other copies across 2 other data centers. So indeed, this is the correct answer. You have 3 data centers. In each of them, you have 2 copies. And in this scenario, you can use quorum consistency level. And you can afford to lose 1 data center completely and still have high availability.
So let's follow up a little bit on high availability. What are the consequences of losing multiple nodes? So we know, you said this already, that with an RF of 3 and a consistency level of 1, we can afford to lose 2 nodes simultaneously and still be online. But is that guaranteed in all cases? Is there a particular scenario where maybe bad distribution of replicas could lead to data loss, or is there an edge case here?
So no, in fact, Cassandra tried to replicate each small range of tokens on different nodes. So losing all 3 replica when you have 2 physical nodes down is not possible. There is still a case where it can happen. It is when you are hosting 2 Cassandra processes on the same physical machine. So in this case, all the guarantees, of course, are off. That's why, in fact, we have a feature in DataStax Enterprise we call multi-instance. It is useful when in some big companies you can only order big boxes. And by big boxes, I mean hundreds of CPU cores, hundreds of gigabytes of RAM, and a dozen of hard drives. So in this case, not to waste all the resources, you can host multiple instances of Cassandra on the same box. But with DSC multi-instance, we try our best to dispatch each replica of the Cassandra node on different physical boxes using drag awareness and so on. However, there is no magic. You should always remember that if you have, for example, replication factor of 3 and only 2 boxes, losing 1 box will surely lead to losing 2 replicas out of 3 for some token ranges, right? No magic.
The no magic. DuyHai said it. It's like your trademark term, dude. There is no magic.
Awesome. Okay, so that's really interesting when you're talking about using some of these big box machines and then the interaction of that with racks. So how does this work with replicate distribution when you have a multi-data center setup?
So as I said earlier, 100% of your data set is replicated inside each data center. So losing a whole DC is not a problem, as long as you have at least 1 DC surviving. Now, there is a subtle detail that most users ignore, which is also each data center manages its own ranges of token. Each token value is cluster-wide. It means that if you are using fixed tokens, like in the old days, the token value on each node, no matter in which DC it is, should be different. So we can see on the internet some blog posts of people giving some rules how to choose the correct token range. So some folks, they are just incrementing by 1 when you switch from one DC to another DC. And that's the idea.
Woo. Okay. Everyone take a second, just digest that for a little bit. That was a lot of really intense information. So, and I appreciate that. I mean, you are definitely an expert in this field. And if you are listening and understanding what DuyHai just told you, your life is going to be a way lot better. But let's lighten it up a little bit. I mean, I think this is, let's get into some fun stuff here. I want to change off from, some of the more technical deep dive details here and just some funny things that you've seen out in the field. Without naming names, we want to protect the innocent. What are some of the funny things that you've seen in the field?
Oh, so very classical story. Some people call me, hey, we have performance issue in production. Okay. But the weird thing is we have the same environment from pre-production and production, and we didn't face those issues. So I asked them, did you have the same data set or the same workload when you tested your pre-production? And they said, yes, of course. We try to replicate the same workload as the production. And so, what kind of CPU do you have? Okay. How much RAM do you have? Okay. What is your disk? Oh, we are using a SAN.
That's always the answer.
wait,
Oh, it gets worse. It gets
no.
worse.
That's
Okay.
not the,
We're all like, oh, that's the
best-
punchline. Oh, no, it's not.
no. That's not the best part
All
of
right.
the story. So those guys say, but you know what? We were benchmarking lots of time, and the performance was great. So yeah, there's no problem. I said, the problem with the SAN is you can benchmark 1,000 times. It doesn't mean anything. Why? Because you never know who is using your SAN. You can be just lucky during 1 month doing some 1,000 benchmark and everything is fine. And then when you get to production, some project, they are just loading a bunch of data using the same SAN, and then it will kill your bandwidth with the disk. That's
Is that what happened?
Yeah.
Oh, okay.
And they say, okay, we understand now.
Some of my,
So in fact,
yeah.
having good benchmark result on a SAN is not a proof at all.
Actually,
Right.
Because
it's a good way to lie to everyone and saying, oh, our SAN is awesome. No,
Well, what if it's not a shared resource, like the case that you mentioned? Is it still a bad idea?
I mean, come on. There's 0 times that SAN is the right answer.
Okay, thank you.
Ever.
so yeah,
Very opinionated.
it's all about predictability. If you cannot predict your bandwidth, in fact, you cannot control your production. Period.
Yeah, and I think that's the key I think that's where a lot of new users stumble into, and that's why you're mentioning it, is because you talk to a lot of new users. These are just things you learn through experience, and hopefully you out there are listening. Please listen, please. There's good body of evidence. Don't think that you're special. That's one of my favorites. Oh, everyone else failed because they're not good at this. We are. How many times have you heard that, DuyHai?
Oh boy.
Yeah. All right. I think we've consumed enough internet bandwidth for right now. DuyHai, thank you very much for joining us today,
Welcome, as always.
and we hope to see you again soon. I'm sure you'll be a host on this as well. So thank you everyone for joining us today. Thank you.
Thank you.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.